Okay, so let's start. So yesterday we learned about the subnetting. So one question first. 192.168.100.100/28. Just tell me the network IP address and the broadcast IP address of particular IP.
192.168.100.0.
I guess no. Is a network IP address and the broadcast IP address. 60. 16 is a network in the broadcast.
15.
But your IP address is 100. .1 is 96. Is your network?
16.0.
Huh?
192.
Huh?
Network IP.
Network IP address.
It would be 192.168.16.0.
Is a 100 network. 192.168.100.
192.168.100.64.
60. Okay, then
192.168.100.127.
127.
255 address.
What's your answer? 96. And the broadcast? 120. What's your answer? Yeah? Calculate it. Please close this door. Fine. Where is home? Venkatesh, what is the answer? Dixit? And Subham Dutt, it's your first class? 75 is your network.
No, 192.168.
Okay. First minute. What is your network IP address?
192.168.100.16/28.
100.16.
16.
Okay. What's your network IP address? Any new? 96, no? Who's your 96? 61. 190? 16 only. Okay. And broadcast? 100.75. Okay. So just tell me, this 100 IP addresses belongs to this network? Starting 16, ending 75. Your IP address is 100. So less than or larger? What's your answer? 192.168.100.96. And the broadcast? 111. Like this. Any new output? Any new? What's your? Still confused? This second one. Okay. Any new answer? No. So just tell me, with this last 28, how many IP? How many networks we have? 4 networks. So 4 networks. 4, 5, 6, 7, 8. 2 raised to 4. 16. Okay. It means what's your first network? 192.168.100.0. Then 192.168.100.16. Then 192.168.100.32. Then 192.168.100.48. So your answer definitely is wrong. It's not a broadcast IP address. Your broadcast IP address might be 31.31. This is your broadcast IP address. Then 192.168.100. 64 or 60? If you are using adding for 16 plus 40, 48 plus 16. Okay, then 80. Then 192.168.100.96. Then 192.168.100.112. Okay. So now what's your question? Like, what's your IP address? 192.168.100.100. So yeah, definitely that IP address is less than this IP address and greater than this one. It means it belongs to here. This 192.168.100.96/28. It's your network IP address, and 192.168.100.111. It's your broadcast IP address. Clear? Okay. Okay, one last. 172.16.14.75/18. Just tell me the network IP address and the broadcast IP address. Huh? And how many networks we have? 4. Okay, 4 networks. Network.
172.16.64.0.
64.0. Okay. 0.0 is first network. And the second? 128.0. 128. 64.0. Karthik? Is it Karthik? Not Karthik. Rakesh, what's the answer? Yesterday I gave you one task, I guess. Rakesh? And Dixit, what's the answer for this? What is the network IP address?
64.0.
64.0, it's your network IP address. It means you are telling me like 172.16.64.0. And what's the
64.
broadcast?
172.16.127.0.
127.0. This is your broadcast IP address. Is wrong? 255. Okay. Correct. But your answer is wrong. Just
0.64 it will come, right?
No, like the network IP is this one, but this is a not perfect answer. It's a not correct answer. Just tell me, this is your IP address 172.168.14.75. Okay. Is it less than or greater than this network IP address? So definitely your broadcast, this is not your network IP address. It's wrong. Then what's your network IP address? 172.16.0.0/18. This is your network IP address, and the broadcast 172.63.255. Correct? Huh? This one, na? 16 dot. Oh, okay. 16.63.25. Okay, like this. Sorry. This one. Okay. Guys, any doubt, any query in this subnetting? Okay, so just tell me. With the /24, how many total IP address we have? Total IP address with this slash value? Host IP address, total host IP address? 256. With the /25? 128. With the /24, with the /26? Okay. With the /23? The /23? Huh? 23?
It's count the thousand.
No, it's not 1,000. I'm talking about the /23. So just tell me how many numbers of zeros we have. I guess 9. What is the value of 2 raised to 9?
512.
Calculate.
That's 512.
512. 512. With a slash 20. So for like this, we have one calculation. Just start your Excel sheet. Now we have to find with subnet mask how many IP addresses we have and how many networks we have. So first, and also we have to find the subnet value. Like you can see here, we are writing here /20, /23, /24. But when you are assigning IP address on any device, so we are not using slash value. We are assigning, as you can see, the 255.255.0 or 255.255.255.0. So just tell me when I'm using /24. Okay, it means initial 24 bits is 1. It means 3 octet is full. So when you are converting that binary into the decimal, so what is your network? What is your value? Decimal value? 255.255.255.0. When I'm using /16, then 0. When I'm using /30, then last will be 0. Initial 30 bits is 1. So first octet full, second also full, third also full. In the last octet, we took 8 bits. It's not a 128. Okay. 1, 2, 3, 4, 5, 6, 7, 6, 7, 8. The last octet you will get this value. Okay. So first one is a 2 raised to 0, 2 raised to 1, 2 raised to 2 like this. So just tell me what is the answer. 252. Okay. 252. Means with the /30, your value is 255.255.252. Suppose you have /31, then we have a specific number IP address. 254. 254. So we have one calculation. Just focus here. So with the /30, so visible? With the /30, with the /32, just tell me with the /32, how many networks you have? How many networks you have with the /32? 1? Huh? In IPv4, how many bits you have? Okay. And you resolve all 32 bits. So how many networks you have? Okay. Let's get one. And how many valid IP addresses you have? Huh? Do minus only. Okay, so with the /32, how many IP addresses you are getting? Only 1. There is no network IP and the broadcast IP in this scenario. Okay. Now suppose I'm using /31. Now how many networks we can use? How many networks we can create? 2. No. How many bits you took from the last octet? 1 or 7? 7. So what is the value? 2 raised to 7. 128. And it means with the /31, we can divide our one network into the 128 parts. Okay. And in a one network, how many IP addresses we have? We took 7 bits. So how many zeros left? 1. So 2 raised to 1? 2. So total 2 IP addresses we have. Total IP, and here valid IP. Network. Now, when you are using /32, so what's your valid IP address? There's only one, nothing is there. So in the with the /32, we don't have a network IP address, broadcast IP address, nothing. We have one specific IP address. Now what the with this 31? We have total 2 IP addresses. One is reserved for the network and the second is reserved for the broadcast. So in a real time, we are not using this 31 because first IP address is reserved for the network, last IP address is reserved for the broadcast. There is no valid IP address. So we are not using 31, size 31 in the real time. Okay. Now with the 30, how many networks you have? So for that also you have to check how many bits you took. With the slash 32, how many bits you took? 0. With the 31, 7, 6, 5, 4, like this. These are network bits, you can say. Okay, network bits. And also we have a host bits. So here also we have a host bit 0. So with the slash 31, how many bits we have for the host? 1. Okay. Here 2. How many networks we have? 64. Total IP address? 4. Valid IP address? 2. With the slash 29. How many bits you took? 5. What is the value? 3. Then 32. 8. 6. Simply minus 2. So like this, if I am increasing like 28, 27, 26, 25, 20, 28, 27, 26, 25, 24. It means I am taking 3, 2, 1, 0 like this. And here 4, 5, 6, 7, 8. So here 128, 64, 32, then 16, 8, 4, 2, 1. Network. And here 1, 2, 4, 8, 16, 32, 64, then 128, 256. And simply valid IP address is minus 2. So you'll get the minus 2. And one more thing. Okay, not here. Then here is 14, 30, 62, 126, 254. When I'm using slash 23, this is our class C. Okay. If I'm using slash 23, then how many bits we took? 7. Your host bits? 1. How many networks? 128. Correct? Total IP address? Total IP address. If you want to find the total IP address, so you have to check the numbers of 0. Like in a class, in IPv4, total bits we have 32, we took 23. So how many bits we have? I guess 9. 9. So 2 raised to 9. 512. So valid IP address 510. Then you are taking the slash values 27, 22. We took 6 bits. Host bit is 2. How many networks we can create? 64. Then I guess 1024. Then when you are using slash 21, we took 5 bits here, 3, then again 32, then here. 2048. Sure. And let's see also I'll calculate it. How many bits we have? 11, I guess. No? 11. So 2 raised to 11. 2048. Then I am taking the 20. Then 4. Again here. 4. 16. Then 4096. 4096. If I am using slash 19. So just focus here. Your network bits is remain same. Like when you are taking the 1 bits or 7 bits, so your network this one. If you are taking the 6 bit, then your network like this. So your network number is remains same, but your numbers of IP addresses is going to increase. So according to this, just tell me, in our class, like we have 25 students. So which subnet mask we can select? I need only 25 IP addresses. So which subnet mask we can select? I can select this one /27. Okay, because with the /27, I have total 30 valid IP address. So from this 30 valid IP address, I can assign 25. So there's only 5 IP addresses resting. No issue. 5 IP, we can compromise it. Now, in your scenario, you have only 2 PCs, point-to-point communication. It means you need only 2 IP address. So which subnet mask you can prefer? /30. Okay. If I have 1,000, then 22. So it depends how many IP addresses you need. According to that, we have to select our subnet mask. Clear? Okay. Now we have to find our number in this form. Like this is our slash values. It's also subnet mask, but in the slash value. I need this format, in the decimal format. So when you are taking this class C, it means 32. So we have four octets. So first octet is full, second also full, third also, and the fourth also full. With the /31, first octet full, it means 255. Second also full, third. Now in the fourth, how many bits we took? 7. What is the value of 2 raised to 7?
128.
128. So, huh?
It's already written.
Yeah, but it's not like this. When you are using the /31, 254. Just 1 minute. It's a 254. It can. Why? Because let's consider here. Yeah. So in the last octet, how many bits we have? 7. Bits is 1. 1, 2, 3, 4, 5, 6, 7, 0. Now just tell me, what is the number? It's a 128. Really? So 254. 254. So here you will get 254. Here we get 128. Why? Because our first bit is a 0 and the rest of all is like something 1. But here our initially 1 and the last bit is a 0. So when you are using the /31, this is your subnet mask. Now when you are using 30, so again initially 3 bits is full, 3 octet. Now here what is the value? Initially 6 bit is 1. Here. 252. Okay. Now when you are using /29, 248. 248. When you are using /28, 240. So like this 0, 128, 192, 224, 240, 248. This is your values. And your first, second, and third octet is full. Clear? Any query? No? Now suppose I am taking these values, /23, 19, 18, 17, 16. Okay. Now if I'm using /23, so what's my subnet mask? 23, it means first 2 octet is full. So 255, 255. Now from the third octet, how many ones we have? One value, 7. So initially 7 bits is 1. So what's your value? 254. In the last, 0. Now again here, first and second bit is full. octet is full, so 255 and 255. What about here? 252. Then 248, 240, 224, 192, 128, then 0. Same values we are getting here. And here all 0. Okay. Now suppose my value is like 15, 14, 30, 12, 11, 10, 9, 8, 7. Okay, 7. Not 7. This much. Now my subnet mask is /15. So what's my subnet mask? First octet is full, 255. Then 7 main. So what is the value? Again 252. Then again same 252. Then here. So you can write like this: 0, then 128, then 192, 224, 240, 248. Here we'll get 252 and 254. Okay. So this number you have to memorize, like 0, 128, 192, 224, 240, 248, 252, and 255. So like this, just check here. When I'm using /9, okay, it means how many bits we are taking? 1 bits. So your subnet is 128, like 0, 128, 192, 224, 240, 248, 252, 254. Like this, you have to memorize. So suppose your slash value is /27. So I guess first, second, and third octet is full. How many bits we took from the last? 3. So again, 128, 192, 128, 192, and 224. So when you are using /27 here, what is the value? 224. Suppose I am using here /19. Then I guess first and second octet is full. From the third octet, how many bits you took? 3. So again, 128, 192, and 224. If I am using /15, then how many bits we took? 7. So again, 128, 192, 224, 240, 248, 252, and 254. So your slash value is 254. Like this, you can calculate. Correct? So suppose I have one IP address here. You have one IP address 192.168.1.10/25. What is your subnet mask in decimal form? 255.255.255. How many bits we took? 1. So 128. You can check here 25. 128. So suppose my value is 29. Then what's my value? How many bits we took? 5. So again check 128, 192, 224, 240, 248. Like this. Suppose you have one value 172.16.47.87/19. Then entirely 224.0. Got it? How can we write our subnet mask in the decimal form? Yeah, because when you are assigning the IP address in the device or in the PC, we have to mention our subnet mask. As you can see here in the CMD also, we have a specific subnet mask. Okay, done. Now our subnetting is done. Now let's move to the different topics. Okay, so before it, just 1 minute. And guys, tomorrow you have to bring your laptops because tomorrow we are going to install some softwares. Like tomorrow we have to install two softwares, GNS3 and the packet tracer. So tomorrow is just an installation part. Okay, so in this scenario, how many IP addresses we need? Two. So which subnet mask we can select? Slash 30. So suppose I'm using 192.168.1.78/30. So just tell me what is your network IP address and the broadcast IP address for this IP. It's easy one. Yeah. What's your network IP address and what's your broadcast IP address? Calculate it. Fine. Anything else? First, tell me, like in one network, how many IP addresses we have? Is it? Huh? Total, how many IP addresses we have, including network and the broadcast? Huh? Including 4 IP addresses. Now just tell me what is the broadcast and the network? 72. It's your network and the broadcast? 75. What's your IP address? 78. 76 is network. And the broadcast? 79. So 76 is your network IP address and the 79 it's your broadcast IP address. Still you are confusing in the subnetting? Like in this scenario, like we have only 4 IP addresses. So starting from the 0 to 3, then 4 to 9, 10 to 13. Like this, we have to calculate it. Okay. So in the laptop 0, I can assign which IP address? If 76 your network IP address, so can I assign here 76? If I'm trying to assign 192.168.1.76. Okay. What's my subnet mask here? 252. What is saying? It's an invalid IP address for this subnet mask because it means we can't assign any network IP address to your system. Okay, we can't assign. So which IP address I can assign here? 192.168.1.77. What's your subnet mask? 255.255.255.252. That's correct.
Sir.
Yeah.
Hello.
Huh? Tell me what I want.
Sir, is there any formula to identify direct means network ID and broadcast ID? Means in this is again I have to prepare 0 to 3, then 4 to 9 like that. Is there any...
See, we have to find. It's not a very shortcut formula, but you can try. Like in this formula, how many IP addresses you have? 4. It
4.
means if n is near to 80, okay, it's near to 80. It means this is my network IP address. I can say this is my one of the network IP address. We can think like this. So because in the one network we have 4 IP address, so definitely this is my one of the network IP address. Okay, and this is the larger of this. It means the previous network, it's my network IP address. So what's my previous network? 76. Like this we can find it. There is no shortcut way.
Okay.
Calculate. You can think like, okay, is a slash 30. So what's the nearest value? Like in the slash 30 we have 4 IP address. It means definitely 40 is a network, 80 is network. 60 also is network. So like this we can find
In slash.
30,
Okay.
because in the we have only 4 IP address. So like this we can find. Just think and find it. Now come to the laptop 2, and here also we have to assign some IP address. Now just tell me which IP address I can assign here. One 192.168.1.77 already I assigned there. It means 78. If I'm trying to assign 79, then 255.255.255.252. Again, it's saying is invalid because this IP address belongs to broadcast. So 192.168.1.78. And the last 252. Okay, so like this we can assign. And network IP address and the broadcast IP address is reserved. We can't assign to any devices. Correct? Okay. Now, come to the new topic. So, any idea like what is the anycast? Or anycast, unicast, multicast, broadcast. What is a domain? Then what is the broadcast domain? Then collision. Then collision domain. So what's the meaning of the unicast, guys? Have you heard about this unicast? One-to-one communication. One-to-one communication, you can say unicast. What's the meaning of the broadcast? Broadcast message. We have one feature in the WhatsApp. Broadcast that message. So one to all. Multicast. One to, you can say one to particular one group. One to particular one group. Like this is one device and this is a second device. When they are communicating directly, it means this is a one-to-one communication. This is our CCNA class. CCNA class. In this CCNA class, we have some students. And I'm your lecturer. So I am delivering some message to you. So in this scenario, what I'm doing? That message is reached to you all, every guys. So I'm doing broadcasting. Okay. And what is this? This is my CCNA class. It means I have one specific organization. You can say CCNA organization, CCNA group. It means this is my one domain. Similarly, I have one more class here. And this is your CCNP. CCNP. Okay. For the CCNP, we have some different trainers. So in the CCNA, I'm delivering some message to you. It means I'm doing one broadcast. I'm doing broadcasting in this domain, in this one particular domain. So what is this? You can say this is my broadcast domain, one broadcast domain. Whatever I'm delivering in this domain, the CCNP guys cannot understand this one. They can't hear my voice and all. When the CCNP trainer is delivering some message to their students, so that message we can't read here. It means this is my different broadcast domain. Clear? Domain and the broadcast domain. Now just tell me what the meaning of collision in normal term. Yeah. Collision. Huh? Like suppose you have this one way road. Okay, you have one way road. Now you have one car. This is your car. You have BMW, you can say. Okay. Now this is your one way, and you are going from left to right with high speed. How many speed? Like, what's your higher speed in the BMW? Huh? Only 240. Okay, that's 240. 240 kilometer per hour. Okay, this is your one way. You are going from left to right. No issue. This is a one way. Suppose there's one stupid guy, and he's coming from the wrong side. Okay, and you can say this also there is one for there's one more car. Not a nano, man. Like Audi. Audi. What's the spelling? AUDI. AUDI. Okay. Audio is, you can say this audio. And also is coming with the higher speed around 240 again. Then what will be happen here? Accident, collision happen in this in this environment. Definitely. Accident happen, collision happen. So what is going on here? Is a traffic jam. Okay. This is a one way, so we don't have any other way to go outside. So the traffic jam here in this environment. Okay. And this collision happen on the one way. So in the networking, we have some terms like duplex mode. Have you heard about the duplex mode? What? Just tell me the modes. How many modes we have?
Duplex, half duplex.
So what the meaning of the half duplex?
We can send other than
Huh?
At a time, one can send.
At a time, only one user can send the data or receive a data. Like a one way. At a time, only one can go from the left to right or the right to left. If I am sending some data, also I'm trying to get some data at the same time. So what's going to happen there? Collision. Because there is only one way. What the meaning of the full duplex?
both send and receive.
Okay. In the half duplex, what is the example except this walkie-talkie? Any? Yeah.
Telephone.
Telephone.
Radio.
Radio. Then? Okay, in the full duplex? Mobile phone. Mobile phone. This is best. We can send a data, we can receive a data at the same time. So your half duplex. In the half duplex, we can get this kind of scenario, collision. And in this scenario, collision occur. So in this one-way road, our collision occurs. So you can say this is my one collision domain. Okay, the one collision domain. Then this one, unicast, one-to-one communication, multicast, one to particular group, broadcast, one to all, domain, one specific organization like Cisco.com, Infosys.com, IBM.com, like this. Broadcast domain, it means I'm delivering some message within my domain. Collision, the section worker, and the domain, it's called a collision domain. Now, tell me in the CCNA how many devices we have? Huh? CCNA normal devices. Like normally we have hub, switch, and the router. Okay, as of now, just consider we have only these three devices. Any idea about the hub? Huh? You already attend this, na? So, yeah, Rakesh and Venkatesh, any idea what is a hub?
Hub is unmanageable device, right?
Hub is unmanageable device, then?
And it is broadcast on all ports.
Okay, before these devices, suppose you don't have any device, okay, and in your environment you have 5 PC, and your task is you need a connectivity from each and every end-to-end communication you need. You don't have any devices, so how can you make a communication?
Hub, sir.
You don't have any device. You don't have hub also. Then, like you have, consider you have some devices. Like this is your device 1, 2, 3, 4. This is your PC.
One way will do one LAN to one LAN.
So I can do like this connectivity. In my PC, I can configure 3 NIC cards. 3 NIC cards, and they can connect like this. Same as like from this PC also, I can connect this NIC card, and here also I can connect. So like that, we can make a reachability. But in this scenario, I have only 4 devices, so 4 PCs, so it's okay, no issue. But suppose you have 5 to 6 devices, then now you can see it's a very messy. You need some devices like this. So it looks like a very messy. So what kind of topology is it? Mesh topology. Have you heard about the mesh topology, star topology, ring topology, bus topology? So what is this? It's a mesh topology. So suppose if we lose one connection, so again we have to check, okay, from which end we lose our connection, and also we have to replace all the cables and all. And also in this scenario, like you can see, we need lots of cable, lots of work, manual work. We have to crimping, we have to connect the cables, we need a long cables and all. So for resolving this kind of scenario, we can use some devices. So first device is a hub. So if I'm putting one device here, it's your hub, first device, hub. And I'm connecting all the devices like this. So which kind of topology is it? Central or star topology. In this, like you can say, it's look quite good. No, there is no this messy topology and all. But in this scenario, if my hub goes down, then we don't have any disability. There is a one disadvantage, but no issue, still okay. So we can use our central device and we can make a reachability from end to end. Okay, so just tell me, if you had this hub, so why they introduced switch? Huh? Doesn't know the exact IP address. Okay. Any other? You are saying switch is smart. So what about the hub? Is dumb device?
They're unmanageable device.
Unmanageable device. Okay. Or you can say it's a very dumb device. Hub is a very dumb device because in the hub, we don't have any parameter. Based on that parameter, it can take a decision. We don't have any parameter. Simply it's receiving any data and is going to broadcast. In a hub, we don't have any mind, nothing.
It's not checking with other.
No. It's simply is receiving that message and flood that message. That's it. So hub is a very dumb device. Don't use hub. Hub is a very dumb device. We don't have any parameter. Based on that, it can take a decision. Now, okay, before it, we have one topics like OSI model. Okay. Today we are not going to discuss about it. Just I'll give you an idea like how many layers we have and in which layer which kind of data we have. On a 4th week, we'll discuss on this OSI model. So just tell me in the OSI model how many layers we have.
7.
What's your first? What is your 7th layer?
Application.
And the first? I'm asking first and the second. First and the 7th. First is
application. First is physical.
Physical layer.
okay. So physical, then
Data link layer.
then
Network.
data link layer, then network layer,
Transport.
transport, then session layer, then
Okay.
presentation and application.
Application.
So physical, data link layer, network layer, transport layer, session, presentation, and application. So your hub is working on this L1,
Physical.
physical L1. Okay. In the data link layer, switch is working. In the network layer, your router. Okay. Physical, hub, data link layer, switch, network layer, router. Okay. Now come here. So hub is working on layer 1, L1 device. You can say it's a L1 device. Now, is our ADM device is working on the layer 1, and also in the hub, we have one broadcast domain. One broadcast domain. What the meaning of broadcast domain? When you are sending the data, is going to broadcast in one particular room. Now, also we have one collision domain. One collision domain. If something happen in my environment, so no one can communicate from one side to another side. It's going to accident, like one way. Clear? So I have one topology. Huh. Here's my topology. Yeah, see it. So this is my one topology. In this topology, I have one device, central device, hub, and also we have some PC, laptops. And in this all the laptop, I already assigned some IP address. You can see 10 network, 10.0.0.1/8 here also. This IP address is gone. In this we have 3, 4, just 1 minute. PC1, PC2, the IP addresses. Four. So this is your topology, and in this topology we have some IP addresses. Now, in this switch, it's a dumb device. We don't have any parameter. We can't do any kind of configuration on it. You can see we don't have any CLI modes, so we can configure this device. Now, this device is working on layer 1, and also in this we have one broadcast domain. So when you are trying to send any packets from the PC1 to PC4, just 1 minute. Now you are trying to send any packet from the PC1 to PC4. So your hub is working on the broadcast. So first is going to receive that message on the particular interface, FA0, fast Ethernet 0. Now it's a one broadcast domain, so it means it's going to broadcast that message like this. Okay, all the users receive that packet. Now PC4 is sending the reply packet. So what is going to do here again? Broadcast, because we don't have any parameters. Third time also. You are sending some packet, it's reached to the hub, and again is going to do broadcasting. So it's a good thing or bad? Only then.
Broadcast is doing other
Then the main disadvantage. Yeah, you are sending some sensitive data, and that data is received to the all of you guys. So if you are, it means you are sending the high message to someone, and that message is reached to the everyone. Okay, so it's a not good thing. And also, if you are sending some sensitive data, like you are sending some bank details or some confidential file, PDFs and all, and that message is reached to the everyone. So it's not good thing. So that's why we are not using this hub. We are using switch. Why? Because in the switch, we have some mechanism based on it. It can take a decision. Okay. One more thing. Yeah. Hub is working on the collision domain. One collision domain. For it. Difference. Okay. So your hub is working on the layer 1, and also it's working on the half duplex. It's working on half duplex. Half duplex means one-way communication. So when I'm trying to send some data from PC1 to PC4, and at the same time, I'm trying to send the data from the PC4 to PC1. Okay. Now your packet is reached to the hub and fire. Okay. Collision. Fire. Accident happens. So if any collision occur in this area, so you can't communicate from any side to any side. Okay, so this is your collision domain. Clear, hub? At the time only you can send the data or you can receive a data. That's it. Close this one. Now we have a second device, switch. This is the second device, blinking one. This is our switch. Switch. So switch is working on the layer 2 device. And in the switch, it's an intelligent device. It means in the switch we have some parameter. Based on the parameter, we can take a decision. So what is the parameter? MAC address. In the switch, we have MAC table. In the MAC table, we have MAC entries. So based on the MAC entry, it can take a decision. Okay, the switch is going to take a decision based on the MAC table. Now, in the switch, by default, we have a one broadcast domain by default, but we can divide. By default, in your switch is working on the one broadcast domain, but we have some concept, we have some parameter based on it. We can divide our one broadcast domain into the multiple broadcast domain. Now collision. So your switch is working on per port collision domain. Per port collision domain. Per port. What's the meaning of port? Physical. And I see. Like, suppose this is your switch. Where is it? This one. This is your switch. Open it. So in this switch, we can see we have some ports. This is your ports. Port 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, you have some port. Like you can see the physical one. We have some ports. So if something goes wrong on this port number 1, so it's not going to affect on rest of all one. If something happen in this port number, but my task is I want to communicate from here to here, we can. Here. In this scenario, we have some port numbers. This is your F0 by 1. F0 by 2. F0 by 4. F0 by 6. F0 by 6. So suppose something goes wrong on this port number. It means collision occur on this port number. So with this port number, we can't do any kind of communication because collision occur on this port number. But if any user wants to communicate from the port number 2 to 6, they can. Why? Because collision occur on this port number. That's why we are saying this switch is working on the per port collision domain. Yeah. Now, you can see here we have some slots, the 0 and the 1. 0, 0, 1, 0, 2, 0, 3, like this. So now, let's verify, like how can we say our switch is intelligent? We need some proof. So come to the switch. So this is my switch topology, small topology. I guess we have some devices, IP address. Yes. We have IP addresses. Now add it, reference. So yes. Now, as I told you, like switch is an intelligent device. It means we have some parameter based on it. It can take a decision. What is the parameter? MAC entries. So come to the switch. First, let's check. Do we have any MAC entry in this device or not? So as of now, you can see we don't have any entry here. Now, we are trying to send any packet from the laptop 0 to laptop 3. Okay. Currently, we don't have any entry here. We don't have any entry. When your packet is reached to the switch, what's our destination? Laptop 3. Okay. In the switch, do we have any entry? No. So what is going to do? Broadcast. Okay. Now open your switch. Again, check the entries. Now we have one entry. When your packet is reached to the switch, at that time it's going to check. We are receiving our data. We are receiving some packet from the laptop 0. What is the MAC address of the laptop 0? This 00606EE5. So it's going to make one entry in the MAC table. This is our MAC address, and we are receiving the packet on which interface? This interface F0 by 1. So we have to mention here F0 by 1. Right? Now, your laptop 3 is trying to send the reply packet. The reply packet for whom? Laptop 0. Do we have an entry in this switch? So when your packet is reached to the switch, so what is going to do? Broadcast or the unicast? We have entry, so it's going to do unicast. Okay. Only first time, not only first time, when your packet is reached to the switch, it's going to check your data MAC table. If you have any entry, so it's going to do unicast. If you don't have any entry, broadcast. Okay. Now third time again, it's sending the packet to the it's reached to the switch. Do we have an entry for the laptop 3? So it's going to do unicast. You can see we have 2 entries. Now just tell me, when I'm trying to reach from the laptop 1 to laptop 2, we have so when your packet is reached to the from the laptop 1 to the switch, what is going to do? Broadcast or unicast? Why? Because we don't have any entry. So let's verify. Laptop 1, laptop 2. The packet is reached to the switch. In the switch, when your packet is hitting to the switch, so first is going to make an entry for the receiving packet, upcoming packet, okay, incoming packet. So we receive one packet on the port number F0 by 3. This is the MAC address of laptop 1. What's my destination? Laptop 2. We don't have any entry. So it's going to do broadcast. Okay. Still we have only 3 entries. Now my laptop 2 is trying to send some packet like reply packet to the laptop 1. So your packet is reaching to the switch. Do we have any entry? Yes. So it's going to do unicast. It's reaching to the switch and unicast. Okay. And we have some aging time, like how long I have to store this data, make entry. We have some data, like we have some time, 300 seconds. If you are not receiving any data between this time, so that entry is going to remain. It means I'm not receiving any packet from this laptop. So after 5 minutes, 300 seconds means 5 minutes. After the 5 minutes, that entry is going to remove from the database. Okay. Any idea about the ARC table? What is ARC? Any idea? It's nothing. Anyone computer branch? Please computer. You know? And you don't know the ARC table. What is ARC? Really? Where is Rakesh? What is the ARC? Why we are using ARC?
IP address and MAC address. In ARP entry, it is showing IP and MAC address. In PC ARP system, I didn't switch.
Okay, so guys, my task is okay. My task is I want to reach it. Huh? Yeah. My task is I want to reach from the laptop 0 to laptop 3. Okay, it means I need a connectivity. It means we have to send some packet from the laptop 0 to laptop 3. Have you ever used ping command? Yes. Ping command, P-I-N-G space google.com something. Okay. Like this, sometimes we are using the ping command for checking the reachability. Ping 8.8.8.8. So yes, we have reachability, we have internet connectivity like this. Now use some. Suppose I am sending the ping command. In this also we have some protocols and all. This is a ping command. What's my source IP address? Is IP address of the laptop 0? 10.0.0.1. Okay, and what is the MAC address? You can see in the last 6E5. That one, MAC address. So 10.0.0.1 is my source IP address. 10.0.0.1 and the MAC address 6E5. Only last 4 digit I am. Now my task is I want to reach from the laptop 0 to laptop 3. What is the IP address here? .3 and 3DA7. 10.0.0.3 3DE7. When you are sending some letter, all this, okay, and then we are mentioning our address, okay, our to and the from, and also you are mentioning your name and the destination person name. Okay, it means we need two kind of data: address and the name. So suppose like your address speaks, maybe name is different, like that letter is belongs to you, maybe sometime belongs to your brother. So maybe name is a different. So logical name, it may be different, but your physical address is permanent. It means for sending your letter, you need your name and the address. Okay. Same like in the networking. We need a two kind of address, logical and the physical. Logical, our IP address. Physical, it means your device MAC address, device name. Huh? So this is your logical address. This is your physical address. When you want to communicate from the laptop 0 to laptop 3, you need your logical address as well as your physical address. So in your PC, initially, like, do you know what the MAC address of my PC? Do you know what is the MAC address of my PC? Okay, we don't know. Okay. But as I told you, if you want to reach from the laptop 0 to laptop 3, that means from this device to this PC, so you need two entries like source IP address, destination IP address, source MAC address, my own, and the destination MAC address. So do you know what is the MAC address of my PC? No, it means we have to resolve that MAC address. For resolving the MAC address, we have one protocol, ARP protocol. By using ARP, we can find our MAC address. We can find our destination IP address, destination IP MAC address. So in the ping, what kind of data we need? We need a source IP address 10.0.0.1. Then destination 10.0.0.3. Then source IP address 6E5. And also I need a destination. Okay, in this scenario, I know what is my destination. So 3DE7. So this is your packet. Ping, source IP address, destination IP address, source MAC address, and the destination MAC address. So by using this data, you can reach from the laptop 0 to laptop 3. And when this packet is reaching first time from the laptop 0 to the switch, so it's going to check your source MAC address and is going to make an entry in the MAC table with the port number. Okay. Now suppose initially we don't have any entry something. Just 1 minute, I have to remove something here. The switch also we have, so first clear. So in the switch, we don't have any MAC address. Okay. And in your devices, in your PC, we have one ARP table. Okay. In the ARP table, we have some kind of data. Like this is my base PC. In the base PC, I have some data. What is it? This is my IP address and the MAC address. This is my gateway IP address and the gateway MAC address. When I want to reach to the gateway, so definitely we have IP address as well as we have a physical address. But if you don't know about the physical address, then we have one protocol like ARP, address resolution protocol. By using this address resolution protocol, we can resolve our MAC address. Okay. Day by day, we'll discuss about the ARP. So my task is, I want to reach from the laptop 0 to laptop 3. Okay. It means I want to ping from 10.0.0.1 to 10.0.0.3. I know my destination IP address. So I'm trying to send my data from the laptop 0 to laptop 3. You can see here, we are generating one packet. It's called ARP. Why? Because we don't know about the destination MAC address. We have one MAC table here. We have one ARP table, but in the ARP table, we don't have any entry. So I don't know what is the MAC address of my destination. So for resolving the MAC address of my destination, we are using. Day by day, we'll discuss. Now, come here. So if you don't know about the destination MAC address, it means I have to send the data to all of you guys. Okay, it means what I have to do? I have to do broadcasting. So this is your layer 2 header. So in the layer 2 header, you can see we have a 12 time F. In the MAC address, we have a 12 digits hexadecimal form. So here we have 12 time F. So whenever you are getting the 12 time F, it means it's your broadcast. It's your broadcast message. 12 time F, it means your broadcast message. So when your packet is reached to the switch, it's going to check first source MAC address and is going to make an entry like this. Now we have one entry. Now it's going to check a destination. In the destination, what's the destination MAC address? 12 time F. Okay, it means it's going to do broadcast directly. Okay. Now, while sending the reply packet, now we have one specific. What's my specific destination MAC address? 6EE5. Do we have any entry in this for 6EE5? Yes. So when the packet is reached to the device, so it's going to check the first is going to check the source MAC address and is going to make an entry. Then it's going to check the destination MAC address 6EE5. So we have one entry in this table 6EE5, and it belongs to which interface? F0 by 1. So it's going to forward that message in the particular destination, particular direction. Like this is going to make an entry. Okay. Now it's going to send it back. Clear? Any doubt? No? And also check here. After sending this kind of scenario, we come to here and check your ARP table. So you can see in the ARP table also we have one entry. In your laptop, we have ARP table. In the ARP table, we have this information. IP address and the physical address. This IP address belongs to which laptop? Laptop 3. And this is the MAC address of the laptop 3. Now from the second time, if I'm trying to send packet from the laptop 0 to laptop 3, source IP address is 10.0.0.1. Destination 10.0.0.3. Source MAC address, I know what's my MAC address. What about the destination? For the destination MAC address is going to check in the ARP table. Now we have one entry in the ARP table, so it's going to mention it. Simply is going to send ping command without resolving the MAC address. Why? Because this time we have MAC address. Okay. So in the MAC, in the switch, We have a MAC table. What's your aging time? Timer?
300.
300 seconds. It's for aging time. In the laptop, we have ARC table. Any idea what's the aging time for the ARC table? Karthik, Dixit, Venkatesh, any idea? What is the aging time for the MAC address? 4 hours. Okay. So 4 hours, your data is there. After that, you going to remove. Okay, this is your aging. 4 hours. Doesn't matter. We have a super storage. Nice. Okay, clear this one? So hub is a dumb device. We don't have any parameter. It's working on the layer 1. It's working on the hub duplex. How many collision domain we have in the hub? 1. In the switch, how many collision domain we have? Per port collision domain. How many broadcast domain we have in this switch? Can we divide? In this switch is working on the layer 2. In the layer 2, we have MAC addresses. Now the next one is a router. Clear? Any doubt in this scenario? No, it's a very basic. Now this switch, router. This router, this one. This is your router. And your router symbol is look like this. This is your router. This is your symbol. You can see the 2 arrows coming inside and 2 outside. In the switch, all arrows are going outside. And this switch, I have one more thing. This switch we are using for the local communication, LAN connectivity. Why? Because in this we have lots of ports. And the router, this is your router. First of all, router is working on L3, layer 3. What is the layer 3? Network layer. Okay. In the layer 2, what kind of data we have? MAC address. In the layer 3, we have IP address. Okay. In this, according to like why we are using the router normally, why we are using the router? Routing information. Also, we are sending some data with the switch. Let's use the best part. Okay. Then. So for why we are using routing for making a connection between the multiple networks. Multiple networks. In the switch, you can see here, I used here switch. In the switch, I'm assigning here 10.0.0.1, 10.0.0.3. It means all are belongs to one network. It means I can use this switch in this client, in this class, or in the lab for making the local connectivity. So router we are using in the end side, edge side, for getting the internet and all. In the router, suppose you have some port numbers. You have some ports. So suppose this is your ISP. Here we have ISP. So maybe ISP assigning some different network. So suppose ISP gave me a one network IP address like 193.0.0.0/. Okay, ISP gave me this network. So we have to assign some IP address belongs to this network here. Okay, this is my one network. Now, in my LAN, which IP address I can use, public or private? Private. And this one is public or private? This is a public. Now, here I have one switch. And you can say this is my local area. So here I can use 192.168.1.0/23. So you can see here different network, here different network. So maybe in this area also we have some different network like 172. And here maybe we have 10 networks. So with the router we can, why we are using router? For connecting two different networks. This is my one network, 2, 3, 4. We have 4 networks, and by using router we can communicate between the 4 different networks. Clear? Now, suppose on this interface, like this interface number is F0 by 0, and here I use 193.0.0.1/24. This is my one IP address, valid IP address. Can I assign on this port number F0 by 1 and the IP address 193.0.0.2/24? Can you assign the IP address? No. Why? Because in the router, we are using router for connecting to different networks. It means on a one interface, we can define one network IP address. And that network IP address, we can't assign on the different networks, different interface. Like this is my IP address, and this is my network information, like this is my network IP address. This network IP address is reserved for this port number. So I can't use this IP address. Why? Because this IP address belongs to this network, and already this network is reserved for the F0 by 0. So we can't assign any IP address here from this network. If you want to assign, use different network. Okay. What it means then? So this is my one broadcast domain. This is my second broadcast domain. This is my third broadcast domain. This is my fourth broadcast domain. It means in the router, we have a per port broadcast domain. Okay. It's a per port broadcast domain. Per port broadcast domain. And also is working on the per port collision domain. The router is working on the layer 3. We have an IP address. In the router, we have a per port broadcast domain, and we have a per port collision domain. Clear? Now, in the switch, we have a MAC address. Based on the MAC table, we are taking the decision. So in the router, we have a routing tables. Based on the routing table, we are taking the decision. Okay? Based on the routing table. Okay. So this is your one of the topology. This is your one organization. Okay, in this organization, and this is your ISP. And this organization, you have some devices. Devices like PC, router, anything you have here. Or assume like all devices are PC. Now I need a reachability between all this PC. So which device I can choose here? Switch. I can deploy one switch here. I can deploy one switch. And I make a connectivity. Like this. Now they can communicate with each other. Now I need an internet. Then we need one router. In that router, we have to connect here. There. This switch is connected with the router. And the router is connected with the ISP. Okay, this is your small group. So guys, any doubt, any query? No? Then online guys, any doubt, any query in this?
No.
No? The answer is correct. Okay, so guys, I'm done with my class today. So tomorrow, please bring your laptops because tomorrow we have to install some software. Software in the sense like we have to install Cisco Packet Tracer and the GNS3. Cisco Packet Tracer and the GNS3. And for this GNS3, we need one more software, VMware. Do you have VMware? So we have to download. Okay. It means we need some software. So I'll send you one drive on the Google. Please download that software. Just 1 minute. What's the time? No, this one. No? to 10. Software. This one. So guys, you can see this is your drive at to 10. In this, we have one software folder. Open it. And you have to download this software first. Okay. You have to download this software. And also we need something like go to the GNS3 website. GNS3 website. From here, you have to select your operating system. Depend on you which operating system you are using. If you are using Windows, also just click on this download and download this file. One more file we need. Scroll down. You can see the GNS3 VM. Open it and download this file. Okay, so tomorrow come with this software, this 3 softwares. Okay.
Only we have to download, right?
Yes, only you have to download. Tomorrow I'll show you how can you install all these things. Okay.
Okay.
Okay, then see you tomorrow. Have a good day.